Okay, this video continues the previous one where I'm doing this problem from Bender and Williamson. And I'm going to carry on. I just did parts A and B. I'm going to carry on with parts C and D in this problem. And I'm doing them down on another page at the bottom of this notebook here. And so let's do parts C and D. Part C says that it wants us to prove false, the following, that A minus B intersect C minus B is equal to A minus B union C. And so I'm going to call this the left-hand side, I'm going to call this the right-hand side, and I'm going to go ahead and draw Venn diagrams that I can fill in that demonstrate. So I'm going to shade in the right-hand side here, or the left-hand side, and then I'm going to shade in the right-hand side in this diagram. And we're going to see that they're not the same regions. Okay? Let's see. On the left I have an intersection, and so I got to figure out where these two regions overlap. The A minus B and the C minus B. A minus B is this one. Okay, and maybe I'll use a different color. Maybe I'll use green. For C minus B is this one. Okay, and I'm doing the intersection of those two. So C minus B is the green one. And I'm doing the intersection of those two, so I'm going to shade the intersection in. Maybe I'll shade it in black. And it's this region where they're both the blue and the green overlap. Okay. Now I'm going to go to the right-hand side. So this is the left-hand side. The right-hand side. What's going on here? I'm going to take A and I'm going to subtract out B union C. Well, first of all, I'm going to go ahead and give a little picture to B union C. It's this thing here in blue. And I'm going to take A and I'm going to subtract that part out. And so I'm going to fill in everything that's in A, but I'm going to cut out the B union C. Sort of snowman shaped region there. Okay, there's A minus B union C. Clearly they're not equal. Okay, so that proves it. And I can use the same sets as before to demonstrate this. In the previous problem, I labeled, I made three sets, A, B, and C, such that we had all 8 possible regions here, and the same set of elements will work for this. I'm not going to do it for every single one of them. Part D says that A intersects C, being a subset of B intersects C, and A union C, being a subset of B union C, implies that A is equal to B. Okay? And we're supposed to show that this is false. And in order to show an if-then statement false, I want to have a true premise and a false conclusion. And let's see, I want A not to be equal to B, in other words. And I want A intersects C to be a subset of B intersects C. I think that if I just make A a subset of B, that works, right? A is a subset of B, and A union C, I think I can just draw C out here like this. And now I got to figure out A intersects C. A intersects C is this green one here, and B intersects C is this larger green one. Okay, so A intersect C is a subset of B intersect C. How about A union C? A union C is everything in both A and C, and that is a subset of everything that's in both B and C. Okay, so this does it, and A does not equal to B here because they're separate. There's some things out here in B that aren't in A. And so this works. This does it. And let me use this as a guide to make some sets. I'm going to go ahead and in the set A, I'm going to put A, the elements A and B. I'm going to put an element C out here, and I'm going to put an element D here. And I'm going to say that A is therefore the set A, comma B. B is the set containing A, B, and C. And C is the set containing A, B, and D. Now we have A not equal to B as desired. We want the conclusion to be false. A intersect C is the AB. A and C overlap on A and B, and that is a subset of B intersect C because B intersect C is also AB, which is equal to B intersect C. Remember, any set is a subset of itself. So this part, the first part of the premise is true. Now how about the second one? A union C is equal to ABD, and I want that to be a subset of B union C. Let's see. B union C is ABCD. And it worked. ABD is a subset of ABCD. The set AB is a subset of itself. Every set is a subset of itself. And A and B are clearly not equal because B has the element C in it and A doesn't. So I've shown that this statement is false. Okay? And I'll stop here on this video and continue with the third video on this set of problems.